Quadratic equations can be used to solve all sorts of classic problems. For right now, on these word problems, I'm going to allow you to use Desmos because oftentimes these solutions are not going to be either integers or perhaps they are going to be numbers that are so large or so small that they're going to fall off of a standard 10 by 10 graph, and that means you're not going to be able to solve them accurately. So the first one is use a quadratic equation to find two numbers with a sum of 24 and a product of 143. These types of problems, this classic problem, can be solved using a system of equations just like we did in the previous lesson. We're trying to find two numbers, so let's just call those numbers x and y. They have a sum of 24, so two numbers with a sum of 24, we could write that as a system, or as one equation of a system is just x plus y equals 24. That would be two numbers with a sum of 24. And then the second part of the system says it also has a product of 143. Product means multiplication, so that means x times y would equal 143. So these would be the two equations in your system. Also, last lesson, I also said that doing everything with elimination works well with everything is just a linear equation, but xy equals 143 is not a linear equation. So we're not going to be able to solve this with elimination, and that is why we first learned how to solve using substitution. So these types of problems should be solved using substitution. You're going to want to solve the sum of the two numbers equation for one of the variables. You do not want to do it with the other equation, with what I have is the red equation, the product equation, because you are not quite ready to solve that type of equation and plug it into the blue equation, because that's going to leave you with a fraction because you would have to divide both sides by either x or y. I don't think you're going to want to do that this early. So instead, we're going to solve the blue equation for one of the variables. It honestly does not matter which one it is. I'm just going to solve it for y. So I'm going to subtract x from both sides, and that means that y equals negative x plus 24. And then I'm going to plug that into the red equation. So that's going to be x times. Now, since I am plugging negative x plus 24 in for y, I'm going to use parentheses. And then that's going to equal 143. We're going to distribute this. So that would be negative x squared. X times 24 would be positive 24x equals 143. And since it does have an x squared in it, we do want to set it equal to 0, just like we've done all the way up to this point. So I'll subtract 143 from both sides. And since there are no like terms, that means I just have negative x squared plus 24x plus, and that's 143, minus 143. Get that right. Equals 0. So the equation that we're going to put, or the function that we're going to put into Desmos is that, negative x squared plus 24x minus 143. So let's go to Desmos, and then I'll type in that function. So again, it is negative x squared plus 24x minus 143. And it does look like I need to zoom out a little bit. And yep, there's the function. And as we look at the x and y intercepts, I'll lock those in. We can see we have an x-intercept of 11 and another x-intercept of 13. So if I go back to my first page and notice that the x-intercepts of 11 and 13, 11 plus 13 does equal 24, and 11 times 13 does equal 143. So our solutions are 11 and 13. Let's try another one. Use a quadratic equation to find two real numbers with a sum of negative 43 and a product of 306. We could solve this very much like the previous example. If it has a sum of negative 43, my two numbers x and y will equal negative 43. And if it has a product of 306, that means x times y will equal 306. So I will solve the sum equation, the blue equation, for y. So I'll subtract x from both sides. So that means y is going to equal negative x minus 43. And then I'm going to plug that in for y in the red equation. So that becomes x times negative x minus 43 equals 306. And this is a quadratic equation. When I take x times negative x, I get negative x squared. X times negative 43 is negative 43x equals 306. Subtract 306 from both sides. So that'll be negative x squared minus 43x minus 306 equals 0. So what we're going to be typing into Desmos is the function negative x squared minus 43x minus 306. So there we are. We have negative x squared minus 43x minus 306. Again, I'm probably going to have to go searching for it. Where's it at? Oh, there I see part of it, and there I see the other part of it. And when I check the x and y intercepts, I have an x-intercept of negative 9. I should just say x-intercepts. X-intercept of negative 9 and another x-intercept of negative 34. And you'll notice that negative 9 plus negative 34 does equal negative 43, so it has a sum of negative 43. And negative 9 times negative 34 does equal 306. So the answers are negative 9 and negative 34. Finally, another classic question involves projectile motion, particularly balls that are being thrown into the air, or in this case, kicked. We have a kicker punting a football. The height of the ball after t seconds is given by the formula h of t equals negative 16t squared plus 50t plus h sub 0, where h sub 0 is the initial height. If the ball is 1.5 feet above the ground when the punter's foot meets the ball, how long will it take for the ball to hit the ground? Okay, so a couple things about this is that we have h sub 0, and what that represents is the initial height, and the initial height is where was the ball when it was first struck. Since this is a punter, punters typically kick the ball by dropping it and then kicking it slightly above the ground. So the ball is going to be 1.5 feet above the ground when it's actually kicked. So the way to write an equation that describes this information is that we're going to replace the h sub 0 with 1.5. So what we're going to be graphing is h of t equals negative 16t squared plus 50t plus 1.5. And we're going to graph that on Desmos and then figure out when does the ball hit the ground. How long is it going to take for the ball to hit the ground? So we go to Desmos and we type in that equation. Okay, so instead of using h of t and instead of using t for time, I'm going to use x because on my device it's a little difficult to get to the t, so I'm going to use x instead. So it's going to be y equals negative 16x squared plus 50x plus 1.5. Okay, and I'm going to have to zoom out a little bit to kind of give an idea what happens to this ball. So there we go. We can see the ball starts down here, and right at this point right there, you can see 0, 1.5. So it means at 0 seconds, the ball was struck 1.5 feet above the ground. And then the ball went up into the air and it went that high. So at 1.56 seconds, it was actually 40.5625 feet above the ground. I can see that from the X and the Y values. And then it started to fall, and it started to drop and started to drop until it got to right here. And notice that the Y value is 0. That represents when it hits the ground, and that it took 3.15472 seconds, according to Desmo, rounded to 5 decimal places, for it to hit the ground. So I'm going to go ahead and I'm going to round that just to the nearest hundredth, and I'm going to say that it's going to take approximately 3.15 seconds for the ball to hit the ground. So I would answer that just simply with 3.15 seconds.